Hey guys, today we're going to be talking about deleting an element from a singly linked list. So let's start with an example of a linked list. We have a list containing three elements, 5, 8, and 15. We have some pointers there. There's a head pointer that points to the head of the list, so that's the arrow pointing to 5. And then we have these next pointers from each node pointing to their neighboring node. And finally, if you notice that the last pointer is a null pointer. Alright, well what does it mean to delete from a list? There's really two types of cases. Case one is what happens if you want to delete the head of the list. So in this case we're deleting 5. Well, let's draw it out. If we remove that node, we're left with the two remaining nodes, and the head pointer has critically updated from what was previously pointing to the head of the list at element 5 to the new head of the list, which is element 8. The second case is what if we were deleting an internal node or a non-head node. Let's say we were deleting 8. The picture that we have under case 2 shows that the head of the list is still 5, but the next pointer from that element, instead of pointing to 8, now has jumped and pointed to 15. Okay, well, how do we write a pseudocode algorithm that describes how do we do this? Let's imagine that the delete API takes in two values, the head of the list and the value that we want to delete from the list. So the first step in either case is we need to find the node that we want to delete. So let's imagine an API call find, which also takes the head of the list and the value we're looking for. So in case 1, we're going to look for the value 5 in the list. We're going to get returned that it's at index 0. And since this is the head of the list, we go into the if case and we update the head to be 5's next pointer, which is 8. And that satisfies the picture that we previously drew under case 1. Now let's do the other case. The else case is we're not at the head of the list, so let's say the value we're looking for is 8, as we previously did. So let's make an API called findPrevious. Given the head and the value 8, we're going to find the previous node. Previous to 8 is, of course, 5. Now we need to update the node containing value 5, its next pointer, to point to current node, which is 8's next pointer, which is 15. So now you've restructured the linked list, and you see what the picture that we've drawn, namely, that the first node, 5, instead of pointing to 8, skips ahead and points to 15. And that concludes how we delete from a linked list. It's pretty simple. Thank you.